All right. It's preparing the
Okay.
live stream.
Cool.
So
We can
I will,
probably look at the live data too.
yeah. Yeah, we can see what's, cooking. So
Yep.
I will go,
If you want to put the live data and do analysis.
yeah. All right.
But we can probably
Preparing the
start.
live stream. Okay. All right. I think we are live. I think we are.
Yay!
I will do, but I'll let it sit for a minute or two to see if anybody joins us because I'm an hour late from from when I said I was gonna be here. But it happens, but we're here.
That's right.
Yeah, it's like somebody had to work and it was a long day. So let's see. You make sure. Make sure we'll go to YouTube. Come on, YouTube. Go to view channel.
Yeah,
Okay.
we got a few people
Yeah,
there, so that's
got a
pretty
few people
cool.
there. All right, so we're good.
Um,
So I will start off with oh yeah, I gotta allow you sharing privileges. So I'll do our official lead in now that we have a couple people watching. So thanks to those that waited the extra hour to get here. In case you weren't aware, I was working down in Tennessee and the event went a little long today because of rain delays. Um, and it was crazy. It was just like little spurts of rain that just came in, just enough to screw everything up. So teardown took a little bit longer, but I'm here. I'm still in my work outfit. Haven't changed. Um, but we have some interesting things to talk about today. Because in case you've been asleep for the past week, we had quite a bit of activity, quite a bit of various different solar storms, various different things that moved through, trying to make heads or tails of what. I mean, we'll go through and try to figure it out. And then we're going to talk about the phenomena of blue aurora, which is something a lot of people saw, and we'll see more of it as because we're leading into summertime where we don't have very much nighttime anymore. So it's kind of an
yep.
interesting thing.
Well, at
So
least for
anyway,
Northern Hemisphere. Southern
yeah,
Hemisphere
yeah,
is doing just fine. They're seeing plenty of
correct.
red aurora.
Yes, correct. So anyway, we'll let if you want to bring up the slides, we can
Yes,
start
I can definitely
start
do
with
that.
our actually, we're going to talk about some current things too that's going on. Um,
Yeah, just a little
with
bit.
yeah, a little bit. So because if I remember correctly, that's how those slides started.
Yep.
Was yeah. So all right.
All right. So this is a little
Here.
bit of kind of current events and what's on the disk at this point. We got three coronal holes. One is probably having some impact right now. And another one, we'll talk about it in a sec, but it was fairly small to begin with, but then eruption happened, and now we see the full extent of it. So it's both rotating in the view, and sometimes you see them better, and sometimes there's another activity kind of pulls off the coronal loops, so we can see the full extent of it. So this one actually is transequatorial, meaning it is facing, not just facing us, it is kind of pointing in our direction. It's not high latitude where it's close to the pole. It's really just in the center, so it can drive some activity. We don't know what type of activity it's going to drive. I think it is actually positive polarity. Yeah, it's a positive polarity coronal hole.
Yeah.
So it's thought to be last year effective, but ultimately, it depends on how strong of the CIR, so how strong of the compression it can cause in the magnetic field. We'll see what happens. And our old friend, the big coronal hole that kept scaring everybody, that's coming back too. We've got my dog barking in the background. Awesome.
I can't hear them, so
Yeah, I can hear her. It's hard to talk over her.
yeah.
She has an opinion. We got quite a few active regions, but most are fairly simple. This one may be something that's interesting. It's beta gamma, so it's a little bit more complex. It's been flaring a little bit, but overall, nothing major and nothing to speak about. So we'll see what it is, as usual.
Yeah.
There was a CME earlier today, and it came from actually a filament eruption. So this is a polarity inversion line. So this is where positive and negative polarity kind of face each other. And there are usually filaments that are hanging in this area, or at least some sort of ready to launch flux rope, and that's exactly what happened. And as you can see, this is a coronal hole just before the eruption. This is what happened after the eruption. So those coronal loops, they're
Actually
close.
pretty cool.
Yeah,
Yeah.
so coronal loops, and when you see that eruption in SDO, if you want to pull it up, of the 24-hour loop, so when you see it in SDO, you see the launch, because the launch itself was fairly wispy, so probably was kind of higher in the corona, so high above the surface, whatever you can call it, of the sun. But it just lifted those coronal loops out of the way to see the extent of it. So it's kind of nice. It's a really pretty event. And this is probably what it is. It is a very slow CME. So probably gonna get a little bit of a push from just ambient solar wind. And it's interesting because those CMEs usually get deflected a little bit eastward, so a little bit in our direction. To what degree, it's hard to know. Again, it's modeled as a glancing blow, meaning it is not directed at Earth, but as it expands when it travels, it just might arrive and sort of scratch us a little bit, but we'll see. The estimates are anywhere from late to midday of June 12th in UTC time to going into June 13th, and there is a huge margin of error. And there is a huge interval even in Huxt. So kind of pretty much more than usual. And the hit rate is like how many of the runs out of 500 actually resulted in arrival? It's pretty low. It's under 10%.
Okay.
So we have to wait and see. There is low certainty arrival and very high uncertainty overall that something will happen. But again, we have to wait and see as usual with those events. This one is not coming directly at us, so we can't count on its arrival. This is what Met Office is doing. So they're running just about any CME that they see that is on Earth-directed side, or Earth-facing side, I should say. So they pretty much modeled everything. We're likely seeing, if we have not seen already, as in it has passed, the arrival of the June 3rd CME. It's probably running through, probably the tail end of it. And then there is a CME that was launched on June 6th, and this is the CME now. There is a coronal hole in the mix, and again, that's the coronal hole that's negative polarity. I think that's actually the one. So I was mistaken. That's a negative polarity coronal hole.
Okay.
So it is modeled to arrive as well. And that throws pretty much the entire ensemble off the track in terms of certainty, uncertainty, and time of arrival. So we're left pretty much this with the same wait and see what happens.
I mean, we saw what happened with this mess last week and how early that CME arrived. So
Ah, yeah. So I think that's where we're getting right now. So
so
just
here
to
we go.
recap, this
Yep.
was the eruption. It was very complex and pretty much, I don't know, not quite the entire disk flew our way, but pretty close to it. It was a
Yeah.
big one. And the speed was estimated from 13 to 1500 kilometers per second, depending on who did the modeling. Arrival at L1 was very fast. So 27 and a half hours transit time. So that's pretty short.
Yeah.
And it did not slow down all that much because the speed at the time of arrival was 1100 kilometers per second.
Yeah.
So
The
from the
one go back
launch to
to the
arrival, it didn't lose much. So why did that happen? Well, it looks like it didn't face much traffic ahead of it. And we were still under the influence of high-speed stream. So we kind of talked a little about it last time that depending on what speed you're entering into your modeling, you can see different times of arrival. So it didn't meet much of a resistance and it probably came earlier than anticipated. What's interesting is Swipsy actually posted one of their models. They usually run several models, and then it's up to forecaster to decide based on their experience and sort of the feel how events will play out. So they have seen this arrival, which turned out to be pretty close to when CME actually arrived, and probably discarded this run as, oh, that's probably too early.
And then isn't that funny? Because that's the one that ended up being correct or close
Yeah.
to correct.
Yep. Exactly. Exactly. But did we see the plasma density that was forecasted? No.
No,
It was, yeah, and again, we really have not seen a whole lot of major events like that that follow high speed stream. I tried to look for literature on CME high speed stream interaction in terms of timing of arrival and the density. There is not a whole lot on it, and we haven't seen fast solar wind. Probably the entire cycle, solar cycle 24, that was going that fast, and the CME that was launched with that speed. So we really do not have any data to know how CME launched into the trailing, sort of trailing CME. So CME follows high speed stream. How that would play out, we probably don't have a clue. So it's hard to model. It was a tough event, and I'm not surprised the timing of arrival turned out to be off just a little bit. It really is kind of within technically the arrival time when you think about the forecasting error. So 10 to 12 hours, that's where it ended up arriving to.
right on that
So
hairy edge.
yeah, exactly. So it's not too bad. It actually did arrive and it caused some decent storming. But this is something we discussed at the last stream. So timing of arrival is affected by the ambient wind. And we were talking about really like ambient wind of really ambient solar wind, which
Right, yeah.
is 350 or so. We were going at 700. So
So double basically.
yeah, double. And yeah, you can cause pretty significant errors with that. So not a surprise. Now we know now that we have seen this event, we
Yes.
know that anything that's launched into high speed stream and fast solar with fast solar wind of 700 will be arriving early. So when it came, it was interesting.
Yeah, this is fun. This is a mess.
It is a mess, but it's a very organized mess, surprisingly enough, because we're seeing the shock. So it really, the BT, the magnetic strength, really jumped big time with a shock arrival, and it went even higher. So sometimes you see the stepwise shock. This is not unusual. It doesn't necessarily mean several CMEs are arriving. It just how it can play out. And then we're seeing one structure and then very sharp change in terms of what the vectors are doing. And there's another structure, another sharp change, and another structure. And then we're finally seeing some negative BZ.
I know.
And
Yes.
then it goes into yet another structure. So we really have seen quite a complex event. And M2M actually commented that over the next 2 days, several things have been seen. So potentially more than one structure, definitely more than one structure, but how many exactly, we really don't know. Then we're seeing another shock. So this disorganized field is sort of another shock. And then there is another CME that was launched after that M8 CME flare. And that actually had some time to play out. So
Yeah, that one actually
interesting.
looks the most smooth out of all of that
Yeah,
last one.
yeah. So interesting thing about this whole thing, there is a little bit of a temperature increase with those transitions, which kind of indicates that those CMEs did interact with each other, probably compressed and heated each other, or not CMEs structures. I don't know what to call them because we really don't know
Right.
how many structures were at play. What happened with density here? Eh, not that impressive.
Hmm.
Not that impressive. Again, launching into high speed stream, which doesn't have a whole lot of density, probably didn't have a lot of density to accumulate on its way. It was already fairly low density, was traveling through not quite vacuum, but vacuous space. And on top of it, it probably expanded quite a bit because usually they do arrive slightly denser than that. This is clear-cut structures that, again, some density spikes during the transition areas, and they're not all uniform. So there are several things, several CMEs in this mess. How many? I don't know. I don't think anybody knows. I've tried to ask SWPC, and they basically said, yeah, that's going to take very extensive analysis, and we're not calling it, which is appropriate. Which
Yeah.
is which is very appropriate. So that tells you that you don't really need high density to see decent storming, very decent storming, and
Yeah.
very nice aurora. So does density drive aurora? Well, this CME just said no.
Hmm. Yep. That's pretty clear.
Does it help to call what's coming? So does density help to tell us what's coming? In most events, yes. So you might see a bump when CME first arrive, and you can sort of see decrease in density as the CME transitions from that initial shock sheath and more of the kind of smooth inner core of it. But no, don't need it. Don't look for it. Doesn't help you. There is no density number that would tell you that you're in for G4 storming.
Yeah, you're
All
right.
right.
So good point. Apt analysis.
And this is what we got for storming. Again, we were doing fairly well as far as auroral activity even before CME arrived. So there was really some negative BZ before it. And we were at G1 storming actually all the way until CME came in and pushed us all the way to G4, so KP8. Um, would you catch Aurora? Would you be able to catch Aurora if you just follow KP? Well, that KP was posted at 3 a.m. UTC. This KP was posted when it was 6 a.m. UTC. And KP8, I don't remember when they posted. They tried to post it as soon as possible, but it was still sometime after CME arrived and went into substorm. So if you wait for KP8, you're probably going to miss some activity. And usually with the shock, we see very nice red aurora,
Yeah.
which fortunately, again, it that storming continued. So it wasn't the same sustained level, but it was continued for some time. So initial probably 9 hours, and we were out of luck for most of it in North America. But that's a different story.
I know. I was gonna say, can you tell when the daytime was for North America again?
Again, yes, that's that seemed to be the case. Or when the Canadian smoke is coming our way. Who
Yes,
can tell
or when
exactly
the
when it was
smoke came in.
happening?
Yeah.
But that's kind of the outline. So you can pretty much tell when we had periods of nice negative BZ because there was some storming along the way, and then finally it sort of calmed down with the I don't know CME number what, but kind of kind of played its way. But
It was a crazy day. What was that? 5 days that we had. When you
It
came to,
was it was 3 days. So
yeah.
June 1st through all the way through June 3rd until it calmed down. And we had some other activity not necessarily related to this event,
Right.
but
Yes. Yeah. So
it was a
yeah,
pretty busy week. Too bad for us. We actually had a lot of Canadian smoke.
yeah, we did.
So
We did.
this is what happens when a nice CME arrives. The auroral oval gets pushed all the way into northern Minnesota, Wisconsin, and Michigan. This is Twin Cities. So this spot right here, that's Minneapolis.
Huh. Yeah, that's pretty
That's
decent.
pretty crazy. And these here,
That's the fires,
um,
aren't
those are the fires. And you
they?
can see the plume of smoke that's extending from that area. And actually, you can probably pick it up here too. But I was shooting a very, very smoky sky. I couldn't see stars. So I tried to step outside and actually see something because I would be able to see it from my location just from home. I could not see a single star in the sky.
Yeah,
So
it's always
that
it's
was that was a
frustrating. Yeah.
huge disappointment. But people who had clear sky, Utah, Colorado, California, Nevada, Tasmania, New Zealand, they got fairly nice show. That goes for Western US as well. So, and was just on the arrival. So it was a very spectacular event. We missed it.
We
Yeah.
missed it.
Canada, can you take your smoke
Yeah.
back? We don't need it anymore. I really feel sorry. It's
Yeah, I
just, it's
do.
been
Yeah.
difficult season for Canada in terms of wildfires, and I hope they can control it soon because it's,
I heard that there's some rain, much needed rain coming through up there. So hopefully that'll help.
yeah, as
And
long as there are no thunderstorms and no lightning, because
yes,
that
yeah,
might
like
ignite additional
rain,
fires.
like just
We don't,
rain, not storms.
we just want rain, not thunderstorms.
Hmm.
And so other things we saw, again, lots of steady magnetospheric convection because BZ was fairly steady with some of the events. And we ended up with the Sawtooth event on June 3rd, and that was going into North American nights. So there was a substorm earlier, and there was another substorm and another substorm, and they were coming anywhere from, I think, 2 to about 4 hours in between, so pretty typical. You need a nice steady negative BZ lower than -5 nanotesla. You end up with periodic substorms and sort of green diffuse aurora in between. Um, you have to wait. You just have to wait. When you see the situation and BZ is not flipping, you have to wait for a substorm. It will happen eventually, but it's just 3 hours, sometimes 2 to 4 hours. You just sit and wait. 3.5 hours seem to be sort of the average time, but it could be anywhere from 2 to 4. Just be patient.
Yep. Yeah, I think that was the night I actually had the one decent night. And it was every, I don't know, 3 hours. It seemed like it was almost on the nose. It would do
Yep,
something.
yep, yep. So, in terms of auroral observation, I think the coolest part, and I am people more than welcome to correct me if they saw something else that was really exciting, but people reported a lot of blue aurora. So this comes from Steve Luther. Hi, Steve. Um, Steve was reported, by the way, too.
Yes.
Again, um, Western United States actually had good visibility, so them and Canada picked up Steve. So that was kind of nice. But blue aurora is fairly rare event. You need a storm and you need a substorm that's pretty close to sunset and sunrise. Typically, it's close to nautical um, twilight, but you can see with strong storming, you can see it even um, sort of outside of that window because what ends up happening is normally you have molecular nitrogen sitting at lower altitudes, but as you have storm going through, all that energy that's being dumped into the atmosphere with substorms and with auroral activity, it actually heats up our atmosphere so it expands. And nitrogen, molecular nitrogen, ends up going up into the atmosphere to sometimes heights of greater than 250 kilometers to, I think Japan reported it up to 500.
That's
So pretty
wow.
significant
Yeah.
altitude where it finally can see the sun and it sort of peeks out from the earth shadow and ultraviolet light breaks it, well, excites it and it starts to go blue. At least that's a current hypothesis. Japanese observations basically stated that you can see that blue even at lower levels where you can't really blame ultraviolet light for doing that color. So blue aurora is something that is still very actively studied. And if you saw it, please report it to both Aurorasaurus and Skywarden. It really helps to both triangulate where that blue aurora is happening and potentially explore why it's happening. Nitrogen that's going up is neutral, but you can see that it is essentially field aligned, meaning it obeys the magnetic field lines. And this is another cool observation, but we can't normally see magnetic field lines. In school, you probably, in like high school or grade school, you probably did experiments with a magnet where you have iron filings and you use them to visualize the magnetic field. Well, Aurora is doing that for us. So that angle, this is what happens with a magnetic field line at the magnetic latitude where Aurora is happening. You can see that it curves. So that's kind of cool.
That is cool. Many
And
cool things about Aurora. That's
yeah, it's really neat about Aurora because it helps us visualize our magnetic field lines.
hmm
There's really nothing like that on Earth that allows you to see that structure of the magnetosphere or structure that you normally don't see. Magnetism and electricity are fairly difficult to visualize for people, and
yeah.
Aurora is a really nice tool because when you see that curvature, you know that's where magnetic field lines are.
Yeah. It's like there you go. You can actually see it. Actually, that's kind of why I've always liked it because it's giving a visual to something you normally can't see.
Yeah. Yeah. All right. So, and that's basically the idea how it works. So, neutral molecular nitrogen is getting fairly high up, or it can catch the sunlight. So you end up with a very nice transition flow from blue to magenta to pink to green during a substorm.
hmm
And yep, you can capture it. And this is where having a short night definitely helps. We will see it more.
Yeah. The positive. You gotta have the positives with the no nighttime anymore. There's one of them.
And solstice is approaching, so we will
It
get
is.
our night
It
back
is.
for Aurora.
Yep. Quickly approaching.
Yep. All right. So finally, this was outside of the event, but this was really cool. So Aurora is happening over here, and Patrick reported this one. And you see this proton blob, which actually looked, at least in the video, it was forming an arc as well. So that's proton aurora caused by precipitating protons, not electrons. So main aurora is electrons and proton aurora is protons that are really just raining out of the sky. It is more diffuse and can be seen as either patches or arcs. It can and will pulsate. That's pretty normal behavior for proton aurora. It doesn't correspond to substorm activity quite like the electron aurora. So it can be seen outside of it and it doesn't really get intensified when we have a big substorm. The aurora intensification, electron aurora, is really several orders of magnitude, whereas with proton aurora, it's about 30% or so, at least, again, statistical data. It could be quite intense at times. So RAGDA, which is a red aurora over green diffuse aurora, can transition into SAR arc, and that requires a fairly strong storm. We have seen it, I think, with May Gannon storm last year and with October 10th event.
Yep.
It was also seen more recently, but there was that was observed in Europe in the beginning of April. So there was another G4, I believe, too.
Yeah.
All right. So I think that about covers it. The only other thing, if we want to take a
Oh yeah, I
look.
could actually bring up that I brought up the video if we want to look at that what happened with the coronal hole. I have
Okay.
that so I could do that.
All right.
So I will share that because it is kind of cool to look at. So let's see if you can see this. I brought it to about where there's our little coronal hole right here. It looks all kind of tiny, but then watch what happens as that eruption happens. It just opens it right up. Look at that. Like that coronal hole was actually much bigger than it originally seemed. So look at that. That's really cool.
That is really cool. And it
Yeah.
probably is not, it's not like that eruption is ripping part of the sun
No,
away.
it's not.
It really is more
It's
loops
very
are just getting out of the way. Yeah,
mm,
it's just opening up.
Yeah, it
So
was very
it's been there all along. It just, we got
yeah.
a better view of it.
So that's always fun when that happens. So I'll look in the chit chats, see if there's anybody asking any sort of questions before we call it. But I think that was a pretty
Yeah.
good analysis of what happened because it was interesting. And I know a lot of people were frustrated because it's like, just trying to figure out what to do and where to go and is this gonna last? Is this it's because it was just so many things and we really didn't um exactly know what structures are what. So, how that goes. All right, now I gotta find it on here.
Yeah, calling structures and saying for sure what happened is impossible.
Yeah. All right, let me take a look see here. It looks like Christian's doing a good job
Yeah.
um answering things. So do. Okay, Glendale. All right. I think we might have covered it all, unless you can see anything. Because I know
Mm,
Tamitha she did a stream on this too, I think.
yep, she did. So, yeah, so Margaret Blue Aurora, yeah, sunlit aurora. Those terms sometimes I used interchangeably. There are things that are called great blue ray aurora, where it is an isolated big ray that's extending very far,
Oh, right, yeah.
very high, and it's an unknown. So if there are any observations of great blue ray aurora, it would be helpful to have it reported. There are some really strange things about it that are still being very actively studied.
Yeah. Yeah. That's the other fun thing is like all this stuff is being, it's evolving science. So like what just happened? I mean, we just don't really there wasn't really anything out there on how a CME launched into high speed stream was gonna really play out. And it was just, you know, some thought that the structures in front of it were going to slow it down. There was, some chit chat that maybe it wasn't going to, or maybe that was pushed out of the way and there wasn't anything there to actually slow it down, which, is what really happened. But, but now we have things to study, and I'm sure somebody's going to study this event, like,
Hmm.
and so because it just helps in the long run trying to forecast these things. But it's difficult. So hopefully, you know, a lot of us missed it.
For a variety of reasons. Yes,
A lot of us missed it. I remember waking
it's
up
okay.
and seeing, I was like, oh my God. Like,
And
that was
I
really,
was awake for it, but I would rather sleep through something like that when there is a lot of smoke. It was
yeah,
just nothing but disappointing because I kept thinking I couldn't fall asleep once I woke up.
yeah,
I was thinking maybe the smoke will clear. Maybe I just need to go to a
right?
different spot in the middle of the night. Nope,
Yeah,
just
because that
way too
smoke
much
was
smoke.
pervasive and it was everywhere.
Um, yep.
So,
The Sawtooth event, I think there was a question about it. Sawtooth event happened
yeah,
on June 3rd,
yeah.
and it was about G3 to G2 storming. When it was going on. It's not necessarily about the level of G storming with the Sawtooth event, because again, it depends on how strong the substorms are. You can see smaller sawtooth events too. It really depends on how much of the solar wind power, so how low is BZ and just how high is the BT, so how strong of the driver we have and how much of the energy steadily being put into the magnetosphere. That's going to depend to drive the level of storming. It's sort of irrelevant almost to Aurora. It's good to know in retrospect, so you can refer to, okay, this was a G3 storm and scientists understand what it means, but you can have a G3 storm where it's one big substorm and the
Yeah,
rest of it is more diffuse stuff, or you can have more of kind of sustained, so it's at that level pretty much all the time. So there is there like they can add up differently in terms of math. And I think there was a lot of confusion about how KP is calculated. So KP is not average over 3 hours. It really is the weighted average of the greatest magnetometer response. So you can have one substorm that basically pulls all the magnetometers or pulls them as the substorm travels through the magnetometers, and you can get to G3. Or the mags are just sitting there consistently all the time, and it's still going to sort of average out as, yeah, it's still a G3. So they can look very differently. And the calculation of KP is very confusing for a lot of people, but that's the maximum activity that was observed over the last 3 hours. And not just last 3 hours, but predetermined 3 hours. So it goes from 0 to 3 UTC, 3 to 6 UTC, and so on. It's those predetermined chunks. SWIPSI is trying to put out that KP as soon as conditions have been reached. So for KP9, they're going to post it right away as it reached because you can't really go any higher. But for
Yeah.
anything up to that KP9, they're going to wait to see whether or not there is a greater response. There is even greater storming that is seen. And if you wait for that, you can miss the best part. So again, KP is sort of good to know in retrospect. It's archival data as soon as it's posted because the activity is over.
Yep. Well said.
Don't use KP. That's like big story.
All
All
right.
right.
See if we have anything else. Um,
Yeah,
yeah,
Proton Aurora was really cool.
yeah, and it was really cool that it was it kind of observed after all this activity went through. So that kind of shows you how some of this stuff is kind of independent of some of this greater activity too, which I guess, re again, things that need to be studied. But yeah, and I think if I remember, if we go back to the Sawtooth event, if I remember correctly, that night was mostly like -9-ish in the
Mhm.
BZ range. So yeah, it was definitely greater than 5, but it wasn't like crazy.
Less than 5 because it's negative.
Yes, sorry. Yeah, less than 5.
Math.
Math, things,
Yep.
tired.
But yeah, and those substorms are shorter because we're not
Yeah.
seeing the full recovery phase. The magnetosphere, we're kind of seeing a mix of both recovery from previous substorm and that steady convection that keeps on going. So you get diffuse aurora and you see that peak activity that's it's gone within 15, 20 minutes. So normally the expansion phase and sort of the good part lasts 15 minutes to half an hour. And then you go into recovery where you get beautiful pulsating aurora and it's sort of um, yeah, it's like natural nature's nightclub. But
Yeah, nature's
you don't get
cycle.
it with Sawtooth events. It's like we're getting cheated of the best part of that flashing the strobes in the sky. We don't get it. We get the diffuse aurora, and that's it.
I know. It is what it is, I guess.
Yeah. Well, they're still fun to watch, and,
Yeah.
and it's important to understand what they are, so you're not walking out of your location thinking
Mhm.
that it's pretty much over.
Right. So that's the point. But I guess on that note, I guess we can call it for the day. But
Yep.
hopefully this helped clarify things.
Even though they have been fairly confusing with lots of different things in the solar wind. Yeah, we got I don't know what got tossed our way. It's pretty.
Yeah, it's fun to get them because it's neat to look back on and you're like, yeah, that was something. That was something. So the sun always gives us things to talk about, which is
Yep,
nice.
for sure.
But as far as next, what do we have next week? Is next week our speaker?
Yes, we have Andrew Renton coming from from Tasmania. Oh, wait a minute, from New Zealand, from
Huh,
Transpower. So
that'll be fun.
they had to mitigate through the Gannon storm, and they did not lose any power, but it was a very big event for them.
So
They
that'll
had
be
to
fun.
take out a couple of power lines because they were seeing pretty significant impact of the stormy weather, stormy space weather.
Yeah, that'll be fun to talk about too. And he's a very animated character. So it'll be a fun conversation.
Yeah,
But
he's awesome.
most of the New Zealanders I've run into are pretty animated. Actually had some today at this NHRA event, and they were also animated. I don't, are they all that way? It's a good
Yeah.
thing if it is.
So
So,
Margaret put in very important correction. So it's giant blue ray aurora.
oh,
They
okay.
are really, really, really tall. So
Awesome. Thank you. Always appreciate the corrections.
yes, absolutely.
We don't we're not the types that, will double down on being wrong. Like just just correct us, it's fine. We're here learning as along with everybody else, so it's all good. All right, on that note, we'll let all you guys be, and we'll see you next week. So thanks for coming along and joining our little stream and our little chit chat. We always love having you guys here.
All right.